Let's review for the exam on Chapter 10. Question 1, let's solve by factoring. The direction says we have to use factoring. And since this is 3 terms, we'll start with the diamond technique. Negative 36 on top and a negative 5 on the bottom. What two numbers multiplies to get a negative 36, but still add up to get a negative 5? That would be 4 and 9. And since it's a negative 5, we'll use a negative 9 here on the right. This factors as x plus 4 times the quantity x minus 9 is equal to 0. Since each of these factors multiplies to give us a 0, it must be that x plus 4 is equal to 0, or it could be x minus 9 is equal to 0. We can now subtract 4 to both sides to solve for x. This gives us x equals negative 4 as our first solution. For the second solution, we'll add 9 to both sides. Adding 9 to both sides, you can see that x is equal to 9. And that's our second solution, x is equal to 9. Sometimes we write our solution as an ordered set. So we have negative 4 and then 9 in curly brackets. We can write our solution using curly brackets, or we could just circle x equals negative 4 and x equals 9. Question 2, it says solve x squared minus 2x equals 4x plus 40. There is no directions on which technique to use. So the first thing I want to do is to rewrite my quadratic in this form. Ax squared plus bx plus c is equal to 0. Let's get it into that general form, and then we'll figure out what to do next. Let's subtract 4x to both sides, and at the same time I will also subtract 40 to both sides. This simplifies our equation as x squared minus 6x, because negative 2x and negative 4x becomes negative 6x, and we also have a negative 40 here on the left, and that's equal to 0 on the right. We can now try factoring. Factoring is the first technique that we always try because it's the easiest technique. Do not always try the quadratic formula or completing the square. Factor first, because that's typically the easiest. And so we have the diamond technique for this question. What two numbers multiplies to get negative 40 and add up to get negative 6? That's going to be 4 and 10, and this has to be a negative 10. This factors now as x plus 4 times the quantity x minus 10 is equal to 0. Since we have two numbers that multiplies to give us a 0, either the first number is 0, or it could be the second factor is equal to 0. For the first equation, we'll just subtract 4 to both sides to solve for x. This gives me x equals negative 4 as our first solution. For the other equation, let's add 10 to both sides. And this gives me, as the second solution, x equals 10. If you're not sure these are good solutions, you could always plug it back into the original equation for each and every single one of these x variables and confirm that these are good solutions. Question 3, it says solve by extracting square roots. So we have to use that technique for this problem. That means I need to isolate that x squared term. We got to get it by itself. We'll start by subtracting 45 to both sides. And so that gives us x squared is equal to negative 12. Since the x squared is now by itself, we can take the square root of both sides. Don't forget, you have to include the plus or minus in front when you take the square root of both sides, always add the plus or minus in front of the radical. On the left, it gives us x squared. This is equal to plus or minus the square root of negative 12. Now, when we take the square root of both sides, don't forget the square term gets canceled out with the square root. So we just have an x on the left, not an x squared. So we have x equals plus or minus the square root of negative 12. When you see that negative inside the radical, pull out the I. So this gives us plus or minus I root 12. This is not over yet. We got to simplify the square root of 12. And so I can rewrite this as the square root of 2 times 3. Looking for groups of 2. And my final answer is plus or minus 2I root 3. This is a good solution. We have two imaginary answers. Negative 2I root 3 and positive 2I root 3. Example 4, again, we must extract the square roots. That means I got to isolate the x squared term. Let's isolate the x squared term. And that means I need to get rid of the 4 and that negative 1. What is first? The first thing we need to get rid of is that negative 1. So let's add the 1 to both sides. This simplifies to 4 times the quantity x minus 3 squared is equal to 300. Now I could deal with the 4. How do we get rid of the 4? We divide both sides by 4. Do not make the mistake of distributing the 4. You can't do that. You have to divide both sides by 4. This results in x minus 3 squared is equal to 300 divided by 4. That's 75. You have to now take the square root of both sides. Once we isolate that x squared term, we're going to take the square root of both sides. So let's take the square root of the left and the square root of the right. Don't forget that plus or minus. If you forget it, you're missing half your answer. So we need that plus or minus. On the left, the squared cancels out with the radical. All I am left with is x minus 3. On the right, I can simplify 75. That's the same as 3 times 5 times 5. And since we're looking for groups of 2, we can bring out that 5 to the front. This is x minus 3 equals plus or minus 5 root 3. I can now add the 3 to both sides. Let's add the 3 to both sides. When you add the 3 to the other side, make sure it's in front of the plus or minus. Do not put it behind the plus or minus. And it just looks better that way. So we'll have 3 plus or minus 5 root 3. This is it. We have two solutions. 3 minus 5 root 3 and 3 plus 5 root 3. Question 5. Let's solve the quadratic equation by completing the square. We have to use completing the square. That means I need to rewrite my equation in this form. X squared plus bx equals to c, so we can complete the square. We'll start by adding 8 to both sides of the equation. That gives us x squared minus 14x, plus we'll leave ourselves some space equal to 8 and some more space. In the spaces, we have to add b divided by 2 squared to both sides. That means the b in our problem is negative 14. Negative 14 divided by 2 squared gives us negative 7 squared, which is 49. 49 has to be added to both sides of the equation. On the left side, it factors as x minus 7 times x minus 7, and that's equal to 8 plus 49, or 57. But I could rewrite the left side as a squared term, so let's write it as x minus 7 squared, which is equal to 57. Now we could take the square root of both sides. Don't forget that plus or minus. If you forget it, you're missing half your solution again. On the left, we have x minus 7 squared. That's going to simplify by canceling out with the radical. That's just x minus 7 equals plus or minus the square root of 57. 57 cannot be simplified. We'll leave that alone. To solve for x, I need to add 7 to both sides. We'll add 7 to both sides. Leave that 7 in front of the plus or minus. Therefore, our solution is x equals 7 plus or minus the square root of 57. This is a good solution. Example 6. Solve using the quadratic formula. Recall the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. This only works if we have the equation written in this form. The quadratic must be equal to 0. And that's great. In example 6, it's already done for us. The a is the number in front of the x squared. The b is the number in front of this x. And the c is the constant term on the right. In our equation, a is equal to a positive 1, b is equal to a negative 1, and c is equal to positive 10. We need to substitute into the formula. Negative 1 is what we have in the beginning. We have a negative, and the b is negative 1, so we'll substitute that inside a parentheses, plus or minus the square root of negative 1 squared minus 4 times 1 times 10. Divide all of that by 2 times 1. The double negative in the front becomes a positive. That's a positive 1, plus or minus. The square root, we have negative 1 squared, that's a positive 1. Negative 4 times 1 times 10, that's negative 40. And we'll divide that by 2. In the top, the radical simplifies to the square root of negative 39 divided by 2. Negative 39, that factors as 3 times 13. So there's no groups of 2. So all we could do is simplify it by pulling out the I. So we have I in the front, and inside is the square root of 39. This is it. This is our solution. 1 plus or minus I root 39 all over 2. Example 7, solve with the most efficient technique. This is great. I can use whatever technique I have at my disposal. Always try to factor first. In this question, unfortunately, it cannot factor because it's in this form. We have a squared plus b squared. This is not factorable. So we can use either the quadratic formula or completing the square, or extracting the square. In this case, I'll choose extracting the square because we have the x squared term. So let's isolate that first. I am using extracting the square roots. So let's do that. We'll start by subtracting 16 to both sides. And x squared equals negative 16. After you isolate that x squared term, take the square root of both sides. Taking the square root of both sides, don't forget that plus or minus. On the left, I have x, and that's equal to plus or minus. There's a negative inside the square root. Let's pull out the I, leaving us a positive 16 on the inside. The square root of 16 is 4. That means our solution is plus or minus 4i. Again, you could have used completing the square or the quadratic formula and still get the same answer. But in my opinion, extracting the square root was the best technique. In example 7, we have to use a U substitution. So the idea is to rewrite it as a power of 2. What goes inside? So we get an x to the 4th back. Well, that's going to be x squared. X squared squared gives us x to the 4th. And that means our U substitution is going to be letting our U be equal to x squared. That's my U substitution. U is equal to x squared. All of these x squareds here will be replaced with the letter U. This is U squared minus 13U plus 36 is now equal to 0. That is great because now I can factor this. Let's use the diamond technique. 36 on top, negative 13 on the bottom. The two numbers are negative 4 and negative 9. This factors as U minus 4 times U plus 9 is equal to 0. Since each of these multiplies to give us a 0, we can set each of these factors equal to 0 and solve for U. U in the first equation, if we add 4 to both sides, is equal to a positive 4. U equals negative 9 in our second equation. But don't stop here. We're not done. We have to use the fact that U is equal to x squared. I'm going to replace this U back to an x squared. We have an x squared equals 4 on the left and an x squared equals negative 9 on the right. Take the square root of both sides, and of course don't forget that plus or minus. That's very important. Half your answer is missing if you forget the plus or minus. On the left we have x equals plus or minus 2. On the right we have x is equal to plus or minus I root 9, and that simplifies to plus or minus 3i. Example 9, we want to solve it by making another U substitution. So let's rewrite it. So we have x squared term on the left here, but we want to get an x back. So what should I square to get x back? That's the square root of x. The square root of x squared gives us x back. So we're just rewriting the original equation so we have that power of 2, that square term that we're looking for. And so what do you think our U is going to be? We're going to let our U be equal to the square root of x. That means this becomes a U squared minus 7U plus 6 is equal to 0. I can factor this now using the diamond technique, and that's negative 6 and negative 1. U minus 6 times U minus 1 is equal to 0. This implies U minus 6 equals 0 or U minus 1 equals 0. Solving for U, you can get that U is equal to 6 or U is equal to a positive 1. But remember, U was originally the square root of x. So let's replace that U with the square root of x again. The square root of x equals 6. The square root of x equals 1. How do you get rid of the square root? You'll have to square both sides of the equation. This simplifies to x equals 36 as one possible solution. And on the other side, x equals a positive 1 as another possible solution. Why do we say that? Well, we squared both sides of the equation. That means we have to check our work in order to get full credit. Let's check our work. Let's check x equals 1 in the original equation. We'll say 1 minus 7 times the square root of 1 plus 6, is that equal to 0? 1 minus, the square root of 1 is just 1, so we have 1 minus 7 plus 6. Is that equal to 0? Yes, it is. So x equals 1 is a good solution And so we'll put a check mark next to x equals 1. That's a good solution. Let's try 36 to see if that's a good solution. Check x equals 36 in the original equation. 36 minus 7 root 36 plus 6. Is that equal to 0? The square root of 36 is 6. And so we have 36 minus 7 times 6, which is the same as 36 minus 42 plus 6. Is that equal to 0? Yes, that is equal to 0. And so x equals 36 is also a good solution. I'm going to put a check mark next to that. We have two good solutions, x equals 36 and x equals 1. In example 10, it says solve. That means we could use any technique we want. And since there's a square root, I'm just going to square both sides of the equation. This gives me 4x minus 24. On the right, I need to FOIL this out. It's x minus 6 times another x minus 6. We must FOIL the right side out first. So let's multiply x times x. That's x squared. X times negative 6. That's negative 6x. Again, we have a negative 6x. And negative 6 times negative 6 is a positive 36. Let's collect like terms. This is a negative 12 in the middle here, a negative 12x, and a positive 36. I want to set this equal to 0. Let's subtract 4x to both sides, and we'll also add 24 to both sides. 0 is equal to x squared minus 16x, and 36 plus 24, that's going to give me a 60. Hopefully this factors. Let's use the diamond technique to hopefully factor this thing. And the two numbers are negative 6 and negative 10. It factors as x minus 6 times x minus 10. And that means x is possibly equal to 6, or x is possibly equal to 10. Why do we say that? We squared both sides way in the beginning, so we have to check our work to get full credit. Let's check our work. Check our work, and we'll check x equals 6 first in the original equation. On the left side, we have the square root of 4 times 6 minus 24. This is 24 minus 24 equals 0. And that's true. The square root of 0 is equal to 0. And so, x equals 6 is a good solution. Let's try 10. We'll plug in the 10 into the x's, and we'll try to simplify this. 4 times 10 is 40 minus 24. That gives us the square root of 16 on the left. And on the right, we have 4. The square root of 16 is 4. That means both of these answers are good. X equals 6 and x equals 10 are both good answers. But we had to check because we squared both sides of that equation. In example 11, it says solve. That means I get to choose what technique I want. I could use the quadratic formula. I could try to factor it or extract the square. In this case, you will realize factoring doesn't work. So we could use the quadratic formula or completing the square or extracting the square. I'm going to choose complete the square. How come completing the square? Well, the middle term is even. So I could easily rewrite this and use complete the square. Since the middle term is even, we could subtract 3 to both sides to set up completing the square. And so I need to add b divided by 2 squared to both sides. That's 6 over 2 squared, which is equivalent to 3 squared or 9. We'll add 9 to both sides of this equation. On the left, remember the shortcut. We can use complete the square very quickly. We just have to take the b and divide it by 2. That's x plus 3 squared on the left, factored. And on the right, we have negative 3 plus 9, which is 6. Now I could take the square root of both sides of the equation. Don't forget that plus or minus. And so we have x plus 3 is equal to plus or minus the square root of 6. We can't simplify that because 6 just factors as 2 times 3. So we can't really find groups of 2. Let's subtract 3 to both sides. And that's my answer. X equals negative 3 plus or minus the square root of 6. In question 12, again it says solve, so we can use any technique we want. You can factor, we can extract the square roots, we can use complete the square, or we could use the quadratic formula. So we have many different techniques, and of course, what's the easiest technique? Well, let's try to factor first. We always try to factor. If that fails, then we'll try something else. Negative 20 on top, positive 1. 4 and 5 seem to work. This is a negative 4. So factoring is the easiest technique for this problem. It just factors as x minus 4 times x plus 5, and that's equal to 0. That means I could set each of these factors equal to 0. And so my first solution is x equals 4. And my second solution is x equals negative 5. All of these techniques would work, but in my opinion, factoring was the fastest and easiest technique. Question 13, it says solve, and I could use any technique that I want. A lot of people might be tempted to FOIL this out, but I think the best technique for this is to extract the square term. Let's extract the square term. And so we will start by taking the square root of both sides. On the left, I am going to take the square root of both sides. And on the right, we're going to do the same thing. Don't forget that plus or minus in the front. It simplifies as x plus 2 equals plus or minus. We'll pull that I to the front. And we have the square root of 169. The square root of 169 is 13. On the right simplifies to plus or minus 13i. We'll solve for x by subtracting 2 to both sides. Don't forget that negative 2 goes in front of the plus or minus. This simplifies to negative 2 plus or minus 13i. This is our solution. In example 14, again it says solve, but it doesn't tell us by what technique. So we'll try factoring first. Let's see if that works. We have a 1 on top, a negative 2 on the bottom, and what number works? Well, it seems like we can actually factor this. This factors as a negative 1 and a negative 1. So this means x minus 1 times x minus 1 equals 0. And so x equals a positive 1 or x equals a positive 1. Since it's the same solution, we just write it once. So we'll say x equals 1 is our solution. And again, I always try factoring. That's the easiest technique. If that doesn't work, try something else. In example 15, we're going to graph this parabola. The first step is to find the vertex. To do that, you use this formula, x equals negative b over 2a. It looks similar to completing the square, but it's slightly different. There's a negative b over 2a. So let's use that. And in our equation, b is the 2 and the a is a 1. We have x equals negative 2 divided by 2 times 1. And that means the x-coordinate for our vertex is -1. But I need to plug that back into the x to solve for the y-coordinate. We'll do the substitution. This is 1 squared plus 2 times. It's actually -1 squared plus 2 times -1 minus 8. So this becomes a +1 minus 2 minus 8. So y simplifies to -9. And so that means my vertex is of the form -1, -9. Let's graph that on the chart here, -1, -9. And that's right here. This is the point. Nope, it's actually down here. This is the point -1, -9. It's down here. So let's erase that mistake on top. So we have -1, -9. And I could just start by putting my axis of symmetry, a vertical line that goes up through the graph. Now there's several things that we know about this parabola. It's facing up because there's a positive number in the front. I know it faces up. So it's a parabola that faces up, and that means we're going to have an x-intercept and a y-intercept. Let's solve for the y-intercept. Next, you let x be equal to 0. The original equation is x squared plus 2x minus 8. Set all of those x's equal to 0 and solve for the y-intercept. So we have y equals 0 squared plus 2 times 0 minus 8. Y is -8. That means my y-intercept, let's write it as an ordered pair, is 0, -8. So we'll put that point here. That's our second point. Now the third point is this point here, -2, -8. That's from symmetry. We have the same distance across this axis of symmetry. Let's find the y-intercept now. To find the y-intercept, what do? We let y be equal to 0. So 0 equals x squared plus 2x minus 8. And this factors as x plus 4 and x minus 2. That means x equals -4 or x equals +2. And that just implies that we have -4, 0 as an x-intercept, and the point 2, 0 as another x-intercept. So let's plot that on our graph. -4, 0 and 2, 0. Let's make sure this is pretty symmetric. Yes, it is. It's symmetric about the y, or the axis of symmetry. It's symmetric about the axis of symmetry. And we'll try our best to connect all of the points in a nice U-shaped looking object. And that is our graph. Quite a lot of work, but the first step is to find the vertex. Find the vertex first. We found that to be -1, -9. The next step is to find the y-intercept by letting x be equal to 0 and solving for the y-intercept. And then finally we found the x-intercept by letting y be equal to 0 and solving for our x values. Example 16, a word problem. The length of a parking lot is 7 yards more than its width. If the area of the parking lot is 60 square yards, find the dimensions of the parking lot. Let's draw a picture of the situation. We know the area is 60 square yards. We know the length. So we have a length here that is 7 yards more than the width. That's W plus 7 for the length. but the width is not given. We'll leave that as W. Recall the area of a rectangle is length times width. So I can replace the A with a 60. The length is, we know, to be W plus 7. And the width we don't know, we'll just leave that as W. We can distribute the W. This gives us W squared plus 7W. Now I'm going to solve for W, which is the width first. And to do that, we'll subtract 60 to both sides. We have 0 equals W squared plus 7W minus 60. Hopefully this factors, and it does. We have negative 60 on top, 7 on the bottom. The two numbers are 5 and 12. We have a negative 5. This factors as W minus 5 times W plus 12. This means the width could be equal to 5 yards, or the width could be equal to negative 12 yards. And the negative 12 yards, that doesn't make any sense, so we're going to throw that out. It doesn't make any sense. We're going to keep the width is equal to 5 yards. But what's the length? Well, we know W plus 7 is equal to the length. So we can substitute into this equation here. 5 plus 7, that gives us 12. 12 what though? It's 12 yards. So the dimensions of this rectangle is 12 yards in length and 5 yards in width. Question 17. It says the two legs of a right triangle are 9 inches and 23 inches. So let's draw a picture of a right triangle. Remember, the legs are the shorter sides of the triangle. So this is 9 inches. This is 23 inches. And we don't know the hypotenuse. We'll just give it a name. Let's call it X. It says round to the nearest tenth. So we'll need a calculator. Recall A squared plus B squared equals C squared. The legs are 9 and 23. So that's A and that's B. We have 9 squared plus 23 squared equals C squared. 9 squared is 81. 23 squared, that is 529. And that's equal to C squared. If we add 81 and 529, I get 610 equals C squared. We'll take the square root of both sides. Don't forget the plus or minus. And we have plus or minus. The square root of 610 is approximately 24.7. We rounded that to the nearest tenth, and that's equal to C. But we can't take the negative. We're going to throw out the negative. We'll just take the positive answer. So C equals 24.7. And in this case, it's inches. Don't forget the inches. The answer is 24.7 inches. In question 18, again, we have another right triangle question. So let's draw a picture of our right triangle. The hypotenuse is given as 15 this time. And the leg measures 12 inches. But we need to know what the other leg is. So we'll give it a name. We'll call that X. A squared plus B squared equals C squared. So we can substitute the legs. A is going to be 12 squared. B is X. We don't know what the B is, so we'll just give it a name. We'll call it X. C is our hypotenuse, and that's 15. 12 squared is 144. X squared is just X squared. 15 squared is 225. We will subtract 144 to both sides to solve for X. And I have X squared. X squared is equal to 81. Let's take the square root of both sides. Don't forget the plus or minus. But of course, in this case, we don't care about the minus. Square root of 81 is 9. And so, what's our answer? Their answer is 9 inches. The length of the other leg is 9 inches. Example 19. This is a quadratic inequality. First step, factor this. This factors as x minus 2 times x minus 10 is greater than or equal to 0. The very first step is to find the zeros. That means I'm going to set x minus 2 times x minus 10 equal to 0. We're just finding the zeros first. And this is easy to solve, x equals 2 or x equals 10. Once you find the zeros, make yourself a number line. That's part of the question. We need a number line. We'll put the 2 down and we'll put the 10 down. And then we decide if we include these as our solutions. If you look, this is greater than or equal. That means I'm going to use closed circles. These are both closed circles. They're part of our solution. They're part of the solution because it makes the equation equal to 0. Then we'll create a chart with some test points. What's a good number to the left of 2? Well, I will pick 0. That's an easy number to pick. We'll pick 0 as a test point. What's a good number between 2 and 10? Let's pick 3. That's an easy one. And on the right of 10, you can pick whatever you want. I'm going to pick an 11. That's an easy number to use. On the top, we'll put our factors. X minus 2, x minus 10. And at the end, we always put all of the factors. And so we'll look at the sign chart. 0 minus 2 is negative. 3 minus 2 is positive. 11 minus 2 is positive. 0 minus 10 is negative. 3 minus 10 is negative. 11 minus 10 is positive. On the right, we have a negative times a negative gives us a positive. A positive times a negative gives me a negative. And a positive times a positive gives me a positive. And that's because these are the factors. For the first row, it's a negative times a negative. For the second row, it's a positive times a negative. And for the last one, they're both positives. So which one of these at the last column, the column on the right, do we need to care about? Well, it's this symbol here. It says greater than 0. That means I want the positive solutions. That is, this row and this row has a positive solution at the end. There's a positive solution at the end right here. Positive, positive. So we look at where the test point occurred. 0 was on the left of negative 2. And this test point was random. That's why we shade the entire left side, because any point would yield a positive result. To the right of the 10 is also positive, so any point on the right of the 10 would be positive. And now we can write our answer in interval notation. It's a parentheses, negative infinity, comma 2, square bracket with a union, another square bracket 10, comma infinity. This is our interval notation. This is our graph. And so that's the complete problem. In the very last question, we're always going to start with the zeros. If you look, the zeros are where the top is equal to 0. So if you're looking for zeros, look at the top. And in this case, x equals negative 6 is a 0. And x equals positive 5 is also a 0. For the bottom, that's where it's undefined. These are not zeros. This is where it's undefined because you can't divide by 0. So that means x equals -2 and x equals 2. Those are not part of our solution set. We'll draw a number line. Include these points: -6, -2. We have a +2 and a +5. Now, -6 and +5, because of this greater than or equal symbol, means closed. -6 is closed, and +5 is closed. It's part of the solution set. If it was a greater than 0, I would leave these as open circles. But since it has an equal sign, we're going to close them up. We have -2 and 2. These are open. These are open because it's undefined. Undefineds are always open. Leave those open. Now this is going to be a huge sign chart because we need to check to the left of -6, between -6 and -2, between -2 and 2, between 2 and 5, and to the right of the 5. So I will start by picking a number to the left of -6. Let's say -7. Between -6 and -2, -3 is a good one. Between -2 and 2, I will pick 0. That's a really easy one to pick. Between 2 and 5, let's say 3. Between 5 and forever, I'll pick 6. On the top here, you put all your factors, each one separately. We have x plus 6, x minus 5, x plus 2, x minus 2, and at the very back, you put all of them. It's x plus 6, x minus 5, over x plus 2, x minus 2. So all of them here on the back side. And then we fill our sign chart. -6, actually -7 plus 6 is a negative. -7 minus 5 is a negative. -7 plus 2 is a negative. -7 minus 2 is a negative. And if you multiply two negatives, and then you divide by two negatives, you get a positive. So at the end, it's a positive result. In the second row, we have a -3 plus 6. That's a positive. -3 minus 5 is a negative. -3 plus 2 is a negative. -3 plus -2, that's still a negative. So we have a positive times a negative. That's a negative on the top, divided by a negative times a negative. Overall, that's going to be a negative. 0 plus 6, that's positive. 0 minus 5, that's negative. This is 0 plus 2, that's a positive. 0 minus 2, that's a negative. And so we have a positive times a negative, that's a negative on the top, divided by a positive times a negative, which is a negative. This is a negative divided by a negative, which is a positive. 3 plus 6 is positive. 3 minus 5, that's a negative number. 3 plus 2, that's positive. And 3 minus 2, that's positive. So we have a positive times a negative, which means it's negative, divided by two positives. That's going to give us a negative result. For the last one, it's fairly easy. It's all positives, and so the last one is clearly a positive result. Now, at the last column, which ones do we care about? The positives or the negatives? Well, that depends on this symbol. This symbol is greater than 0, greater than or equal to 0, so I want to look at the positives. If it was less than or equal to 0, you would be looking at the negatives. So we're looking at the positives, which is this one here, and this one here, and of course the bottom one. That corresponds to -7, 0, and +6. So we'll shade where the -7 was, which is on the left side of -6. We'll shade the 0, which was between the -2 and 2. And then on the right side of the 5 where the 6 was. This is our answer as a graph. Now we could state our answer in interval notation. The solution is -infinity, comma, -6 with a square bracket because it's a closed circle, union, -2 to 2, parentheses for both because they're open circles, and then we have another union, square bracket, 5 to infinity. What a good problem. We have 3 intervals connected together. And that completes the review for Chapter 10. Good luck on the exam. If you have any questions, please don't hesitate to ask.